Okay, today we're studying right triangle trigonometry, and we're going to start with a right triangle. And don't think of trigonometry as anything scary. It's not like you hear trigonometry and it's Mufasa. Ooh. What we need to think of with this, let's go back to words that we already know about triangles. If I have a right triangle, when we're dealing with this right triangle trigonometry, the first thing I want to look at is my angle. It's going to be one of our two acute angles, not the right angle, but I start with the angle because our angle in that right triangle, we're looking at these sides that are making up the triangle. So from this angle across from this, we say that's the opposite side, and that's terminology we've used before. That's our opposite side, and then right next to it, that's our adjacent side. And we're talking about the legs of the right triangle, the two sides that are making the right angle. Those are opposite and adjacent. And they're determined by this angle. That's what determines our opposite and adjacent sides. Across from our right angle, that's our hypotenuse. Always. Hypotenuse is always across from the right angle. Only right triangles have a hypotenuse, and it's opposite the right angle. So we start with our angle, and it determines these three sides that we're talking about within that triangle. Now, the other part of right triangle trigonometry, we've just finished studying special right triangles. Well, this is going to work on all triangles, and our special word here is SOHCAHTOA. Now, how we spell SOHCAHTOA is a big deal. That helps us line up all these ratios that we're going to be talking about. So our way to help us remember this, we have some old hippie caught another hippie tripping over alligators. So we spell that out, and within each one of these, let's just break this apart. We have S, that is for sine. This C over here, that is for cosine. And this T right here, this is for tangent. And we have these special buttons on our handy dandy calculator where we have our sine, our cosine, and our tangent. And all those are is ratios. So when we get into these triangles, we're talking about this angle right up here, theta. We commonly use these Greek letters for variables with our angles. So we're talking about the sine of theta, or the cosine of theta, or the tangent of theta. And all that is a ratio. We've already worked on similarity. We've done ratios before. That's all this is. It's a ratio. And the other parts of this, then when I look at SOHCAHTOA, I have SO is dealing with sine, and I have the O and the H. O is for opposite, H is for hypotenuse. So that's my ratio, opposite over hypotenuse. In all right triangles, the sine of the angle is equal to the ratio of the opposite side over the hypotenuse. And in a cosine, here I am now on the ca in SOHCAHTOA, cosine, we have our A and our H. That would be adjacent over hypotenuse. And then for tangent, pay attention to our spelling. TOA, tangent is opposite over adjacent. Again, these are just ratios, and I'll show you how we're going to use those here in a second. So when we're spelling this out, that's why it's so important to spell it correctly, is because that helps us set up those ratios properly. So if I have a right triangle, and let's say I have two sides. So I have triangle ABC, and I'm given this side is 3 and this side is 4. Now remember, for all right triangles, we also have that Pythagorean theorem, a squared plus b squared equals c squared. And the a and the b are the legs. C is the hypotenuse. So in this case, if I wanted to find the hypotenuse, I could take 3 squared plus 4 squared equals c squared. Or maybe you remember 3, 4, 5 triangle. That's one of our Pythagorean triples. That's a shortcut. If you don't remember 3, 4, 5, or whatever the Pythagorean triple might be, we can always go back to that Pythagorean theorem. Now for these ratios. If I were just talking about the sine of angle A, that means I'm starting with angle A. Here's my angle A. That means over here, 3 is my opposite side. And that also means that 5 is my hypotenuse, 4 is the adjacent. So the sine of angle A, opposite over hypotenuse, that ratio is 3 over 5. If I were to talk about the sine of angle B, then that changes my opposite and adjacent sides, because then I would be looking at, so now when I'm looking at angle B, that has now changed. So now the 4 is considered my opposite and the 3 is considered my adjacent. So my ratio then for the sine of angle B, here's opposite over hypotenuse. It's still sine, so I'm still using my SOHCAHTOA opposite and hypotenuse. Now that would be 4 over 5 because the angle has changed, so the ratio changes. So we could go through and do this then with cosine of A, cosine of B, tangent of A, tangent of B, and as our angles change, so do those sides. So we have cosine of A, here's my angle A, so now I'm looking at, pay attention to the colors, I have opposite is 3, adjacent is 4, so for cosine that's adjacent over hypotenuse, that'd be 4 over 5. Or tangent of A, tangent is opposite over adjacent, so 3 over 4. So all we're doing right here is kind of showing what those ratios are, and it's all about identifying the sides. So now pay attention to my color change. I went now to angle B. So if I'm at angle B, now I'm considering the 4 as my opposite side, the 3 is my adjacent. So for cosine, that is adjacent over hypotenuse. That would be 3 over 5. And tangent of B, tangent is opposite over adjacent. Opposite over adjacent would be 4 over 3. So here's an application of how we can use SOHCAHTOA. Now on this triangle, as far as what we're given for information, it's a right triangle, so we can use SOHCAHTOA. I have an angle here of 35 degrees. Remember we said, first thing, we're going to start with the angle, because the angle determines opposite and adjacent. Now, as I'm solving a problem like this, when I look at, hey, I'm starting with the angle, here's my 35 degrees, I'm looking for side X, and I can see it's across from the angle. That's my opposite side. And then I'm given, here's my right angle, I'm given the hypotenuse. I'm only going to label these two sides for this particular problem because they're the only ones involved in this. This side, I'm not looking for it, I'm not given that side, so I'm not even going to label it for now. I'm just looking at, okay, this one's opposite, this one's hypotenuse. So as far as setting up my ratio to solve for X, when I look at SOHCAHTOA, opposite and hypotenuse, that's here with sine. So that means when I set this up, and our setup is the same every single time, we just need to figure out whether we're using SO, CA, or TOA. So the sine of the angle, in this case my angle is 35 degrees, is equal to opposite over hypotenuse. My opposite is my variable X, that's what we're looking for. Hypotenuse is 12. Now from here we are using algebra to solve. I'm solving for X, trying to get it by itself. Using inverse operations, I'm dividing by 12, so I'll multiply that over. So it's 12 times the sine of 35 degrees. And this is where we get out our handy dandy calculators. One thing to point out on this, I'm going to check the mode, and I want to make sure I'm in degrees and not radians. Radians is another way of measuring angles. We're not using that. We have an angle here of 35 degrees. We want to make sure we have our calculator set in degrees. And so now I'm just going to plug it in just like this. I have 12 times the sine of 35. And our approximate answer for X, we would say it's approximately 6.9 centimeters. Let's say our directions tell us to round to the nearest tenth. Then we would say that side is 6.9 centimeters. In our next example, we are, again, here's our angle. We start with the angle. So if I'm thinking SOHCAHTOA, start with the angle, that determines opposite and adjacent. Well, if this is my angle, this side's next to it, that is adjacent. Here's my hypotenuse again. Adjacent and hypotenuse, that is over here in the middle. Adjacent hypotenuse, that's cosine. So we start cosine of the angle. That angle is 28 degrees. that is equal to adjacent over hypotenuse. My adjacent is 11. My hypotenuse is the variable. So this one's a little different than the last example. We have our variable on the bottom. My first step is still the same. I would multiply that over. So we have y times the cosine of 28 is equal to 11. Now I'm solving for y. To get y by itself, now I'm going to divide both sides by that cosine of 28. So it's going to look like y equals 11 divided by the cosine of 28 degrees, and I can plug it into my handy-dandy calculator just like that. So we have 11 divided by the cosine of 28. And we get our approximate answer to the nearest tenth of 12.5, and our label on that one is inches. In our last example, again, we're still going to start with the angle, but notice this time we're looking for an angle. But we are still going to use SOHCAHTOA. And our first step is still the same, and that is we start with the angle because the angle determines our opposite and our adjacent sides. Now in this case, opposite and adjacent, again, think of SOHCAHTOA. TOA is that last part, tangent, opposite, and adjacent. That's how we're going to set this up. Here is our variable theta. The tangent of the angle, that's what we don't know and we are looking for, is equal to opposite over adjacent, so 3 over 4. Now we can actually solve this for the angle. So when we have this 3, 4, 5 triangle, we're given these two sides. I can figure out what that angle is going to be. Now, here's my variable and we're solving for that. Remember, to get the variable by itself, we use inverse operations. So the tangent of the angle is a ratio. On your handy-dandy calculator, we have tangent, but then we also have, if we hit second tangent, we have that little -1 right there is telling us that we're talking about the inverse tangent. So just like multiplication and division are inverses of each other, addition and subtraction are inverses of each other, the inverse tangent is our inverse operation of tangent. So anytime we're looking for an angle, you will always use inverses. Whether it's inverse sine, inverse cosine, inverse tangent is based upon the problem. But if you're looking for an angle, that means you're going to be using inverse of that operation, of that function, whether it's tangent or sine or cosine. And again, we go to our handy-dandy calculator. I hit second tangent. There's our inverse tangent. And then our ratio is 3 over 4. And that means that our angle is about 37 degrees. So theta is approximately 37 degrees. Now, on any of these examples, if we were asked to solve the triangle, what that is asking us to do, when we are done, that means we're going to have all three sides, and we're going to have all three angles. So when you solve the triangle, that means you have everything about it. Now remember, if I know that this is 90 and I just solved this one's 37, to find all the angles, well, remember, triangles add up to 180 degrees. And we have 3, we have 4. Remember, we can use Pythagorean theorem to find that third side. So if we're asked to solve the triangle, what that tells us is we're going to find all three sides and all three angles, and then we will have solved the triangle.